Okay, so we have these two quiz problems. And here are the answers, but let's see how we get to them. First of all, we kind of want to always have this example in mind. X squared times x cubed, and it could be x to the 14th times x to the 38th. But I choose two small exponents, smallest non-trivial exponents I could choose, so it doesn't take long to write it out. So x squared is x times x cubed is x times x times x. So now we have 5x's multiplied together, and that's what x to the 5th is. It tells you why you add exponents when you multiply. Same number, different exponents. Okay. Here we raise x squared to the 3rd power, and what's that mean? It means you got 3x squareds multiplied together. And each x squared has an x times x, and that leaves 2 times 3 or 6 x's in a row here, and that's x to the 6th. So right here is when you multiply two numbers to the same base. And here's when you multiply your powers, when you take a power of a power. Very important. Okay, and here's how it works out, and it's very straightforward. So I just said, you could write this out. You could write 3 x's and 2 y's in parentheses and then do 4 of those. And you count them and you'd have 12 x's and you'd have 8 y's. There it is. Okay. And you could do something similar with this, but it gets a little more complicated. So it's easier just to write the x to the 5th times x to the 4th first, because the order and grouping of multiplication of a series of multiplications doesn't matter. You can reorder them, regroup them any way you wish, which is what I've done here. And then the y's in another group. And now I see that x to the 5th times x to the 4th. Again, series of 5x's multiplied by a series of 4x's gives you a series of 9x's. And a series of 3y's and a series of 4y's gives you a series of 7y's. And there it is. And if you just quote the rule, you're adding your exponents on each of these. Okay. Okay, now I just briefly explained something about a penny on a system that's rotating, and we got it rotating fast. The penny slid off and landed in a cup, and I said that was impossible, but it happened. Okay, we do the physics analysis. Here's a picture of it. Here is all the stuff that goes into analyzing this. A is just a number, Y cup and X cup are just numbers that correspond to where the cup is in the coordinate system. It doesn't matter for what we're doing. And this squiggly thing is actually called the sine of theta, where theta is this angle. You don't need to know that. All you need to know is if I put all the numbers in here, this is what I get. Okay. And this funny symbol here is like a Greek X. I didn't use X here because I had X down here. But for the purposes we have, you can ignore that fact. And I'm just going to write the same thing with x's. Right there it is. Okay. Now this is called a polynomial. And the thing that's interesting about this is just that what happened could not have happened according to the laws of physics. There's simply no way that it happened, but it did happen. So we're trying to do experiments and figure it out. And these things pop up. And they pop up in other applications. So you kind of want to be aware of them. They're really pretty simple. Polynomial is just this series of powers of x, okay, with numbers in front of them. Numbers in front of them are called coefficients. And all the powers are integers, okay? They're positive, not non-negative integers. They're whole numbers, okay? You don't have a 4.5 power. You don't have a 3.02 power. It's 4, 3, 2, 1. And this is a 0 power. As you find out, when you really, if any x to the 0 is 1. Anything to the 0 power is 1, 20 rules of exponents. Okay, so this is called a polynomial. One thing you study in pre-calculus is when is a polynomial equal to 0? Okay. Now, the original polynomial, when it's equal to 0, that tells us theoretically where the penny was when it flew off. That's not important for what we're going to do here. So here's an example of a polynomial. That's all we're saying. Okay, well, let's take this polynomial. Let's call this polynomial P. And I ask, if I add 1200x cubed to 200x to P, which is our polynomial, what do I get? Well, if I add this to this, I say, okay, well, 3200 x to the fourth plus 900x cubed plus 5400 x squared minus 440x minus 3200. Put that in parentheses, that's P. And to that I add 1200x cubed plus 200x. What does that equal? Can you write that out and write out what that equals? Okay, well, I threw this up as a trial balloon. Sort of started losing a little bit of hair. It wasn't terrible. Everybody has the right instincts, but you got to sort out what you can do and can't do. Now, when you took your algebra courses, you talked about like terms and unlike terms. Okay, so it comes down to you can add like terms. 900x cubed and 1200x cubed are like terms. Okay, so if you got 900 of them and 1200 of them, you have 2100 of them. It's still 2100x cubed. Okay, here you got 900 little packages, each one is an x cubed. And you got 1200 little packages, each one is an x cubed. You put them together and you're going to have 2100 little packages, and each of them is an x cubed. That makes sense? They aren't x to the sixth because you're not multiplying this by this. If you're multiplying this by this, then it'd be a multiplication. And you could multiply. I mean, you could multiply this by this, okay? We're not going to do anything that complicated right now, but it's pretty easy to multiply terms like this, but we're not multiplying them, we're adding them, okay? If we were multiplying, then you would have, among other things, 900x cubed multiplied by 1200x cubed. Be over a million x to the sixth, and a bunch of other stuff, okay? But when we're adding, we just add. So again, 900 of these and 1200 of these makes 2100 of them, okay? So let's look at what we've got. We got 3200 x's to the x to the fourth terms, and there are no x to the fourth terms over here. So we're still going to have 3200 x to the fourth. What else do we have? Well, we've got 900x cubed here. And look over here, we've got another 1200 of them. That makes 2100 of them. So that's so whatever x is, you multiply 3 of them, x times x times x, whatever number x stands for. You multiply 3 of them and you get what x cubed is, right? And then here you're gonna have 900 times that number. Here you're gonna have 1200 times that number. It's gonna give you 2100 times that number. Now we got 5400 x squared, no x squareds over here. Okay. And then we've got minus 440x and plus 200x. Well, you got 200 of them, you take away 440 of them, you're gonna have negative 240 of them. Whatever number x is, this is 440 times that number, this is 200 times that number. So if you add these two numbers, you're gonna get negative 240 times that number x. And then you have negative 3200. So now if I tell you what x is, like if x is 2, you can plug those numbers in. Okay? Now what we're actually trying to do with that polynomial I showed you, this polynomial, is determine the number you would put in that makes this whole thing 0. By looking at that system and where it was in rotation, where I think it would have been if the penny was going to go into the cup, I decided that that angle ought to be about 310 degrees, so that x would be about 0.64. Okay. If I put 0.64 in and it comes out 0, then that tells me something important. Now I put in 0.64 into this, and it came out like 100. Well, with all these big numbers here, 100 is pretty close to 0. Okay. So the point is, there might be reasons for putting numbers in for x. Okay. And the reasons you're going to see in applications are probably not going to be that one, because that's way too complicated. Okay. You know, if you've been through a good trigonometry course, a good pre-calculus course, or the full pre-calculus sequence, then you'd be in shape to understand more about that system. You still wouldn't understand the physics, but you'd understand the mathematics of it. And that's, of course, where we're trying to get you, to where you can start that sequence and learn to do more complex things with the mathematics. And depending on what field you're going into, you might not even get to the trigonometry part of pre-calculus. You might take the pre-calculus course, and then maybe you just take a statistics course, or a statistics course and an applied calculus course, where you wouldn't see this model. Okay. In a full calculus course, you could see something like this. All right, now my whole point is that's where we are. That polynomials are important in pre-calculus and in the courses pre-calculus prepares you for. And here's one thing about polynomials that I think you understand, and by the time you've done the open math assignments, you're going to understand it perfectly well. Okay. Again, x just stands for a number. It could be 0.64, it could be 0.65, it could be 0.63, something in that range would make this 0. And finding where polynomial 0 is a big deal. But what you got to understand first is that these powers just stand for powers of numbers. X is just a variable that stands for various numbers. Okay. Now, let me check something real quick. Make sure I'm telling you something's going to actually help you with your homework, and that will. First thing you learn to do with polynomials in the homework is add them. Okay. Okay, well, I just talked about wanting that big polynomial to be 0. And if you plug in 0.64, you get something that's relatively close to 0, but it's not really 0. In the case of that polynomial, the number that actually gives you 0 is probably a number you can't even write down because you're just keeps going forever without repeating or terminating. So infinitely long decimal number, okay? So it's something you could get close to zero. You get as close as you want to zero, but you'll never actually get zero. Even though there is a number that makes it zero, we don't know how to find it, okay? So, question now, what is P when X equals 2? Well, it's going to turn out to be 0. Now, everybody got it, so. So everybody got down to this. Now, one person forgot the negative sign in front of the 4. You're watching me too much, because I do that all the time. So don't do like I do like I say. And then I can do the -4, and then I can add my positive numbers, and I get 4. And that equals 0, okay? So the way open math is going to say, here's a polynomial evaluated for X equals -3. It just means, plug in -3 for X and do what you just did, okay? Might not have come out 0, but it's good you're going to get something. And you're going to understand real quickly what it means to evaluate a polynomial. Okay. Now let's do a little bit more with polynomials. Let's try. I'm going to say expand. Six x squared multiplied by 4x cubed minus 3x plus 5. That means multiply through by the 6x squared. I think you know what that means, so I'm going to let you give it a try. And if you don't, we'll explain it. Even if you do, we'll explain it because distance students also use these videos, or at least they're available. We want to explain everything for everybody. Okay, well, now we want to use what's called the distributive law. It means if 6x squared is multiplied by this stuff in parentheses, then the 6x squared has to multiply every term in the parentheses, which gives us 6x squared times 4x cubed minus 6x squared times -3x times 3x, sorry, I used the negative there, plus 6x squared times 5. And then 6 times 4 is 24. X squared times x cubed is x to the 5th. Matter of fact, that's the exact example we used at the beginning to determine whether you're going to add the exponents or multiply them. Okay, then we're going to have -3 times 6 is -18. X squared times 3x is x cubed. And then 6x squared times 5, well, you're going to multiply the 6 by the 5 and get 30. And you get the x squared. Now, most of you just wrote down the answer, and I think everybody pretty much had it right. But I really want you to write down the intermediate terms or emphasize it using the distributive law. When you write these out, when you do them for homework, write them out on paper and write them out in detail. Because that'll reinforce something that otherwise you're going to be more likely to stumble over later. Okay? So it's kind of important to write out all the steps. And you're going to see one reason why it's important. I'm going to ask you to do it slightly more complicated. I'm borrowing some of the terms from this, but not all of them. So right there is just what I'd like to see you work out. To the best of your ability, I want to see what you do, but I'm going to take a kind of a quick look, because if nobody knows what to do, I'll interrupt you and we'll go through it. Okay, now, people stumbled a little bit on this because, of course, you haven't done this. Just wanted to see if anybody knew what to do. Well, here it is. Okay. You kind of want to lock this in. Okay. If I multiply this by this, that means I'm multiplying 6x squared plus 5x by 4x squared. Okay, because just like I multiplied the 6x squared times the 4x cubed, I'm multiplying a 6x squared plus 5x now by 4x squared. Okay, so whatever I did with the 6x squared here, I'm going to do with the 6x squared plus 5x here. Okay, and that is I multiplied by the 4x squared, and then I multiplied by the 5. Does that make sense? Okay. Whatever's here has to multiply this, and it has to multiply this. And a plus this. Okay. So this times all this is this times this, plus this times this. Okay. Now that I've done that, well, let's say I've done the first step. Write that down and let's see if you have a good idea what to do next. It's kind of intuitive. You've probably seen it before. And if it comes out of your memory, you're going to know it better, but I'll just give you a couple of minutes. Okay, people are doing a good job of picking up the pattern, not doing a good job of writing out a step like this. Okay, and I really want you to write out that step because it reinforces the law. Okay, and if you skip that step, I don't think you're going to retain it as well. I think you're probably going to be okay with it. I think you're probably going to get right answers. But if you do the intermediate step, you'll understand it more deeply and retain it much better and be much less likely to screw it up. So here we go. I think everybody saw that the 6x squared has to multiply this and 5x has to multiply this. Well, we write it out that way. 6x squared multiplies to 4x squared. Okay? That's 6x squared plus 5x. That 5x also multiplies to 4x squared. So we do plus 5x times 4x squared. And now we've got this multiplied. Now you got another step. We don't want to skip to that next step, no matter how tempting it is to save time, because it only takes seconds to write out this intermediate step and be sure that you have it correct. Okay, so it's then. Going to do the same thing over here. We're going to multiply 6x squared by 5 and then plus 5x times 5. So this equals this equals this equals 6 times 4 is 24. X squared times x squared is x to the 4th. And 5x times 4x squared, 5 times 4 is 20. X times x squared is x cubed. And 6x squared times 5, well, 6 times 5 is 30. You still got the x squared. And 5x times 5 is 45x. And that's it. And I think that's what I saw. Now, there are a couple little glitches. It's easy to forget to put the plus here. Okay. So if you say, okay, 6x squared plus 5x times 4x squared is 6x squared times 4x squared plus 5x times 4x squared. There it is. And 6x squared plus 5x multiplied by 5 is 6x squared times 5. There it is. Plus 5x times 5. That's the pattern. That's the distributive law. And if you understand that and reinforce it, you're going to remember the distributive law. Okay? And it'll be there because it's almost there already. Okay, y'all. had a pretty good background, and you bring some things that mainly just need to be refreshed into this course. Now you're gonna learn some new stuff, but this is all stuff I think most of you've seen before. Okay, try to be systematic with this and write out every step. And again, if you're in class, I'm going to keep an eye on you, and if things start going down the wrong path, I'll interrupt and we'll clarify. Okay, now what most people have done, and it's a perfectly correct step, is essentially they've done this, and here's the way I would want to see this written out. First, I would want to say, okay, I want to multiply the 2x times the x cubed minus 3. And then I'm going to take care of the x plus 5 after I get this. So I put parentheses around the part that I'm going to simplify. Having done that, I go ahead and multiply this out. So this is going to be 2x times x cubed minus 2x times 3 multiplied by x plus 5. We're not trying to multiply everything all at once, okay? So then we multiply this out, 2x times x squared gives us 2x to the 4th minus 6x. Now that multiplies x plus 5, and now we're on familiar ground. It's no different than what we did here, okay? So we pick two of these terms to multiply. We don't try to multiply all three at once. That would get really, really confusing, okay? Even an experienced mathematician wouldn't do that unless they are just really good at putting symbols together, and some are, okay?
And put it to memory.
So is this what the test is gonna be on?
Most PhD mathematicians would multiply this in 2 steps the way we go, just to be certain that they don't mess up something. Okay, people are doing quite well. Okay, so and some people started trying to do too much at once, but once we got that straight, it came out very nicely. So we get down to this step and we see that we got 2x to the 4th multiplied by actually the way I've done it, 2x to the 4th minus 6x multiplied by x plus 2x to the 4th minus 6x multiplied by 5. That was another way I could have written this. I could do 2x to the 4th times x plus 5 minus 6x times x plus 5, okay? So you have the choice of doing that, or doing it the way I did, or just did this whole thing times x, and then plus this whole thing times 5. All right, and that's the way I did it over here, so I choose to continue to do it that way. No matter which way you do it, you're going to end up with 2x to the 4th multiplied by x minus 6x multiplied by x plus 2x to the 4th multiplied by 5 minus 6x multiplied by 5. Now, when you do that, you get 2x to the 5th minus 6x squared plus 10x to the 4th minus 30x. Now we're going to write that in order of powers, order of exponents, okay? We don't want to have an x to the 4th following an x squared. It's not absolutely wrong to do this. It's just going to be harder to use this and combine it with something else if we don't have the exponents in decreasing order. So we write 2x to the 5th plus 10x to the 4th minus 6x squared minus 30x. Okay. That makes sense? So that's, I believe, what you should get. Let's check it. Let's just let x equal 2. Now, 2 to the 5th power is 32, so that's 64. X to the fourth is 16, that's 160. So we got 64 to 160, which is 224. Now the numbers get a little easier. Then we subtract 24 here, which gives us 200, and we subtract 60, which gives us 140. Question mark, I did that in my head. If we plug in here, we get 4, and then x squared minus 3 is just 1. That's 4 times 1 times 7, which is 28, which isn't equal to what we got down here. So something got messed up. And someone's got their hand up already telling me that I did something really dumb. Let's see, that's minus, and that's minus, that's plus, and that's plus. Okay, okay. Hey, don't even breathe loud. Somebody might identify you. Come on, I hit the pause button. Whatever you do, don't laugh in a way it can be identified. I know you're holding that in. Okay. Yeah, okay. I did something careless. Pretty dumb. I had a square here and then I wrote a cube, didn't I? Okay. Which is why this doesn't agree with this. Okay, question mark. WTF, you know what that stands for, don't you? Means what's this foolishness? Okay, now, the original meaning of that term, which I coined 50 years ago, has been perverted into something that really doesn't mean anything. But what's this foolishness certainly has meaning. What's going on here? Well, somebody pointed out that I screwed up my exponents. I couldn't find any place where it's, well, it's here. This x squared, this is supposed to be x cubed. Okay, now, of course, I did that on purpose so I could show you how to check and show you that it really does work. And if you believe that, go ahead and laugh, but wait till I pause the video. Okay. There's a really important pattern that this is going to anticipate. What's x plus 4 quantity squared? The strong temptation, and I did this once or twice when I was first learning algebra, and got out of the habit because I was always checking my work, and I found that it didn't check out. And then I kind of hit myself on the head, and that's why I end up the way I am. But kind of, slap my forehead. Okay, duh. This is not x squared plus 4 squared. No. That's easy to confuse because if it was x times 4 squared, then it would be x squared times 4 squared, right? But that doesn't work with plus. And you can test that. If x equals 2, then this is 6 squared, which is 36. This would be 4 plus 16, which is 20. Okay, so this wouldn't have the same value as this one did, even at x equals 2. Okay. What you would do is you write out x plus 4, which most people did. And then you use a distributive law. And that's very simple. So kind of make sure you don't make this mistake because it throws everything haywire and nothing's going to check. Okay. And also I analyze that fairly strictly on a test. Okay. That's right. Okay, so I think everybody's going to be fine. We're out of time. So and some people already have the right answer, and I think everybody else, if they don't have it, they're about to get it. But I can write this. Now I'm going to do this a little differently. Because we can do this distributive law like this. X plus 4 times this is x times this plus 4 times this. Okay. Previously, I just said I do x plus 4 times x plus x plus 4 times 4. Well, it's correct either way. So you really have your choice about how to do this, and you'll see this in open math. So we get this, and now we get x squared plus 4x. And 4 times x is 4x. And 4 times 4 is 16. Now, the arithmetic is so simple here that I didn't write out the step as explicitly as I usually do. And there are intermediate steps that you might consider writing out here, but it gives you this, okay? So that's a very important application of the distributive law that will occur on your homework. So I think you see everything you're going to need to do your homework. You know, see what open math has to say, look at their examples too, see how they explain it, and put it all together so you understand it and do everything right, and you're going to be happy. And that'll make me happy.